The bucket came down exactly the way it had 1,000 times before, and then it stopped dead like it had hit steel. No warning, no gradual resistance, just a sudden, jarring halt that every operator on that crew instantly recognized as something other than normal ground. Within seconds, radios were crackling and machines nearby were slowing down. Whatever that excavator had just found underground, it wasn't dirt and it wasn't an ordinary rock either. By the time the crew finished piecing together what they were looking at, they were staring at the possibility of a buried deposit that some on site started estimating could be worth as much as $452 million. Whether that number holds up is a different question entirely, and we're going to walk through exactly how a claim like that gets tested, piece by piece, the same way any real mining operation would have to. This story follows a placer mining operation in gold country, run by a veteran operator we'll call Cole, the kind of crew that spent seasons learning to read ground the hard way, through thousands of hours behind the controls of excavators and wash plants rather than through guesswork. On the day this all started, it was a completely ordinary shift. Excavators were cutting into the pay layer, haul trucks were shuttling material to the wash plant, and everyone's focus was on keeping production steady before the season's water license ran out. Then one bucket reaching down into a section of ground that hadn't looked any different from a surrounding area hit something hard enough to stop the machine mid-swing. The operator backed off, tried a different angle, and hit the same resistance again. That's the moment everything changed for the crew, because in placer mining, a sudden hard layer showing up in an unexpected place is one of the few things that reliably makes an experienced miner stop and pay attention. At first, the obvious explanation was a boulder, since buried rocks that size aren't unusual and don't normally mean anything special. But when the crew cleared the loose material away and looked at what was underneath, the pattern didn't match a single rock. Instead of one isolated obstruction, they found what looked like a continuous hard surface extending in more than one direction, sitting beneath layers that looked noticeably different from the ground around it, compact gravel in some spots, a dense clay-like material in others, and what appeared to be an old bedrock surface underneath all of it. That combination is exactly what gets a miner's attention, because it's also exactly what you'd expect to find if you'd stumbled onto the edge of an ancient, long-buried river channel. It helps to understand why old river channels matter so much in this kind of mining. Thousands of years ago, water moving across a landscape carries all kinds of material downstream: sand, gravel, silt, and in gold country, small particles of gold that have eroded out of mineral veins higher up in the mountains. Gold is dramatically heavier than the sand and gravel around it, so as a river's current slows down, even slightly, the gold tends to drop out first and settle toward the bottom, sinking into cracks in the underlying bedrock, collecting in low spots, and concentrating wherever the water's energy briefly eased up. Over centuries, rivers shift course, entire channels get buried under new layers of sediment, and what was once a riverbed ends up sitting quietly underground, indistinguishable from a surface until someone happens to dig into exactly the right spot. When that happens, what looks like ordinary ground can turn out to be sitting on top of decades or centuries of naturally concentrated gold. So when Cole's crew found that unusual hard layer, with its distinct gravel, clay, and bedrock pattern, the ancient channel theory wasn't just an exciting guess. It was a genuinely reasonable hypothesis worth testing carefully. But a hypothesis is not proof, and this is exactly where a lot of amateur excitement online gets ahead of what any responsible mining operation would actually do. The crew's first move wasn't to celebrate. It was to slow down. That decision to slow the machines instead of digging faster is worth explaining, because it's counterintuitive if you don't understand placer mining. Every bucket of material an excavator pulls out gets mixed together once it's loaded, so if a crew rips through a promising layer too quickly, they lose the ability to know exactly which depth or section any given amount of gold actually came from. That destroys the information they need most, a clear map of where the good ground is and where it isn't. So instead of pushing forward blindly, Cole's team carefully separated material from the newly discovered layer, keeping it apart from the regular pay dirt, so that whatever came out of it could be traced back to its exact source. The first real test was a simple pan sample, the oldest and most basic tool in placer mining. A shovelful of material from the unusual layer went into a pan, and slowly, through swirling water, the lighter sand and gravel washed away, while the heavier material sank to the bottom. The first thing worth watching for in that concentrate is black sand, a mix of heavy minerals that tends to travel with gold because it's also dense enough to settle out of moving water. Black sand by itself proves nothing, since plenty of ground has heavy mineral concentrations without meaningful gold. But when that pan also revealed small flakes catching the light against the dark sand, it gave the crew their first real physical evidence that this layer wasn't just geologically unusual, it might actually be carrying value. Still, one good pan is nowhere near enough to justify a headline number like $452 million, and Cole knew that better than anyone watching from outside. Gold in old river channels is notoriously uneven. A rich pocket can sit right next to ground that's almost completely barren, sometimes only 20 or 30 feet away. So the next phase of testing had to answer a much bigger question. Was this gold concentrated in one small spot, or did the same pattern extend across a wider area? That question required test holes, drilled at multiple points around the original discovery, some close by and others farther out in different directions. Each hole gave the crew another cross-section of the ground beneath them, and three things mattered most in each one. First, the thickness of the gravel layer, because a thin streak of gravel can only hold so much material, no matter how rich it is. Second, the depth of the bedrock, since gold settles most heavily right where gravel meets solid rock, especially in cracks and depressions in that bedrock surface. And third, and most important of all, whether gold actually kept showing up at a similar depth across multiple holes. A single rich sample proves almost nothing on its own. A pattern that repeats across several drill holes spread over a meaningful distance is a completely different kind of evidence because it starts to describe the shape of something continuous rather than a lucky, isolated hit. As those results started coming in, Cole authorized a larger test, running a batch of material from the new layer through the actual wash plant, the same equipment used to process the operation's real production ground. This matters because a hand pan only tells you about a shovelful of material, while a wash plant run processes a genuinely significant volume, giving a far more reliable read on the actual gold grade, meaning how much gold shows up on average per unit of material processed. When that cleanup came in stronger than the crew's typical production ground, it was a serious result, the kind that makes a mining operation start taking a discovery seriously rather than treating it as a curiosity. But even then, an experienced operator like Cole understood the danger of getting ahead of the evidence. One outstanding cleanup can still just mean the excavator got lucky and happened to scoop up a naturally concentrated pocket. The only way to know the difference between a pocket and a genuine deposit is repetition, testing again and again from different points, and seeing whether the results hold up. This is also the point in the story where it's worth pausing on where a number like $452 million would even come from in the first place, because it's easy to throw a figure like that around without explaining what actually has to be true for it to mean anything. An estimate like that starts with the size of the potential gold-bearing area, meaning how far the promising layer of gravel and bedrock actually extends underground based on the pattern seen across test holes. Then comes the thickness of that pay layer, since a thin streak of good ground holds far less total material than the same grade spread across several feet of depth. From there, the crew needs an estimated gold grade, essentially how much gold is recoverable, on average, from each unit of material processed, based on results from multiple test cleanups rather than a single lucky one. Multiply the estimated total volume of pay dirt by that average grade, and you get a theoretical total amount of gold that might exist in the ground. Then, because no wash plant recovers 100% of the gold present in any given run, that number has to be adjusted down by a realistic recovery rate. Only after all of those steps does multiplying by the current market price of gold produce something like a gross value estimate. A number like $452 million, in other words, isn't something a crew pulls directly out of the ground. It's a projection built on assumptions about area, thickness, grade, and recovery, and if any single one of those assumptions turns out to be optimistic, the real number can shrink dramatically, sometimes by an order of magnitude. It's also worth being blunt about something a lot of viral mining content glosses over. Gross value and profit are two completely different things. Even in a best-case scenario where a deposit really does hold that much recoverable gold, actually reaching it costs real money, and often a lot of it. If the promising layer sits deep underground, the crew first has to remove everything sitting on top of it, sometimes thousands of tons of overburden, using excavators, dozers, and a steady fleet of haul trucks working long hours just to expose the pay layer. The deeper an operation digs, the more it has to worry about groundwater seeping into the pit, which can require running pumps around the clock just to keep the work area usable. Pit walls also can't just be dug straight down, especially in loose gravel and clay, because unstable walls can collapse, so safe slopes and benches have to be cut, which means moving even more material just to reach the target layer safely. Every hour of equipment run time burns fuel, Every part eventually wears out and needs replacing, and every mile a haul truck drives to reach the wash plant adds cost. A deposit can be genuinely enormous on paper and still be only marginally profitable or not profitable at all if it's too deep, too diluted, or too expensive to reach safely. That tension is exactly what a crew like Cole's has to weigh in real time. Move too fast on early promising results, and you risk pouring fuel, labor, and equipment hours into ground that turns out to be a small, isolated pocket rather than a real deposit, an expensive mistake that can eat into an entire season's budget. Move too cautiously, spending weeks drilling and sampling before committing to anything, and you risk burning through a limited mining season, since most placer operations only have a set window before water rights expire or winter shuts everything down. There's no perfect formula for that decision. It comes down to reading test results honestly, resisting the pull of excitement after one good cleanup, and building enough evidence across enough locations to make a confident call before committing the whole operation. So where does that leave Cole's crew, and where does it leave that $452 million figure? Based on everything described here, it's a genuinely interesting geological lead, an unusual hard layer, distinct gravel and bedrock patterns consistent with an old buried channel, encouraging early pan and cleanup results, and the beginnings of a pattern across multiple test holes. That's real, tangible progress, the kind of thing that gets an experienced mining crew excited for good reason. But it is not, at this stage, $452 million of confirmed gold sitting in the ground, and it's important to be honest about that distinction rather than letting an exciting number run ahead of the actual evidence. Numbers like that are best understood as theoretical ceilings, describing what could be true if every assumption about area, thickness, grade, and recovery holds up under further testing, not as a confirmed discovery. What happens next for a crew in exactly this position is more drilling, spread out wider than before, to map how far the promising layer really extends in every direction. It's bulk sampling, processing larger and larger volumes of material rather than relying on small hand samples to get a more statistically reliable read on the average gold grade. It's additional wash plant cleanups from multiple separate locations, watching closely for whether the strong results keep repeating or start to taper off the farther the crew moves from the original discovery point. And it's careful bedrock mapping, tracing the shape of that old buried surface to understand where dips, cracks, and low points might be concentrating gold most heavily. Only once all of those pieces line up consistently, across multiple independent tests rather than one exciting cleanup, does a claim like this start to move from theory towards something closer to a proven deposit. That's really the heart of every gold mining story like this one, whether it plays out on a real claim or in a piece of storytelling built to explore how these discoveries actually get evaluated. The moment an excavator hits something unusual is genuinely exciting, and it's completely reasonable for a crew to feel a jolt of adrenaline when the first pan comes up loaded with color. But the distance between that first exciting moment and an actual, provable, profitable deposit is enormous, and it's filled with exactly the kind of careful, unglamorous testing described here. Sampling, drilling, cross-checking, and resisting the temptation to believe the biggest possible number before the ground has actually proven it out.